Great job! You made it through the first mini class. Now that your head is stuffed with killer information on what front-end is from a high level, let's jump into the technology behind front-end. The front-end stack is made up of many different languages and libraries. While these vary from application to application, there are just a couple of generic languages understood by all web browsers. We will first go over those, and then dive deeper into libraries and frameworks prevalent in the tech industry today. The three main front-end languages are HTML, CSS, and JavaScript. This probably isn't surprising. Let's explore each one individually as they are the underlying scaffolding that web browsers use for rendering. All other libraries in front-end engineering are built upon these three main languages. HTML creates the code version of a wireframe on a web page. These exist for our styles in CSS and all our bells and whistles in JavaScript. If we go back to my scaffolding analogy, think of a web page like a house. The initial UX design is the blueprint. HTML is the basic structure of the house. The CSS is what makes the house look attractive. JavaScript is the inner workings of the house that we, the owner or renter, use and enjoy. HTML is the first layer of a website. HTML stands for Hypertext Markup Language. The markup part of this name is the most important to remember, as that is the proper name for HTML elements, which are also called HTML tags. HTML is what we actually see on a page. It is the markup that creates basic elements that we view on a website. HTML isn't particularly intelligent. It doesn't make decisions or capture information on its own. It simply renders the scaffolding. CSS, which stands for Cascading Style Sheets, is what gives our HTML visual appeal and draws in the user. In short, style sheets dictate the presentation of HTML elements on a page. CSS is what makes everything not look like a white background with a bunch of Times New Roman text and blue hyperlinks. Have you ever tried to load Amazon on a bad day and seen nothing but a white page with a huge list of black text, some blue links, and nothing else? That's Amazon loading without styles. Styles are what transition beautiful designs onto a site. A new trend with styling is to use what is called a CSS preprocessor. These include Less, Sass, and Stylus. Preprocessors are scripting languages that compile to CSS for the browser. Preprocessors are very popular as they expedite development process. They accommodate some programming logic, they consolidate styling through usability, and they scale easily for use with large websites. Most front-end engineers of all levels have experience with preprocessors due to its power and flexibility to suit all scenarios, from building small single-page websites to enterprise applications such as Groupon or NBC Universal. Now let's dive into the deep end, JavaScript. JavaScript is a runtime language for web browsers. This means when a page loads, any custom JavaScript added to a page will load in parallel with it and can perform actions and make decisions. JavaScript differentiates from backend languages such as Java or Ruby in that JavaScript is visible to the user and is not compiled ahead of time to run secretly behind the curtain. JavaScript is the true programming language of front-end engineering. The frameworks and libraries we will explore in a moment are all written in JavaScript. It is the underlying language that ties everything together. A great example of JavaScript in action is OpenTable. Once we decide, I want a table for two at 7 p.m. in Seattle on July 25th, a list of restaurants with tables to reserve shows up. From here, we can look at a map with the list alongside it. The map with all the restaurants is actually Google Maps, with custom JavaScript built on top of it. When we click on a map marker, we get a little flyout with the restaurant information on the map, and the list of available locations automatically scrolls to the restaurant that corresponds with our selected map marker. If you click on a time listed for a particular restaurant, you're taken to a reservation page with the restaurant's information and the time you select. All of these custom elements, interactions, and transitions on the site are done using JavaScript. Because, as I mentioned earlier, all the necessary JavaScript is already loaded on the page when we visit it, we as users don't experience any lags or stutters when we click on a map marker. The code is already in the browser and ready to go. It's helpful to understand these types of front-end interactions. Why? The next time you look at a candidate's online profile, you can make an informed guess on what was built using JavaScript and ask the candidate, "So, I see a lot of powerful user interactions here. Did you build those using JavaScript? This demonstrates credibility as it communicates that you understand how the web works, and you recognize the abilities of a candidate like myself. And you are doing it in a way that isn't making an assumption that I may have to correct and educate on later. It starts a conversation around what technologies a front-end engineer is excited about and used on that project. Now that we know what if the problem is popular or interesting enough, this is often when an engineer will build a library or a framework to address the needs of the programming community at large. JavaScript in particular has a great deal of open source solutions, as the user interactions and design on sites vary widely, but there are indeed common elements and user interactions across different applications. Now, let's dig into a few popular and widely adopted libraries and frameworks. JavaScript has, since 2006, been ripe for abstraction and improvement. A JavaScript library is a set of functions that allows engineers to complete useful tasks in areas like audio-video treatments, calendars, carousels and sliders, maps, charts, touch interfaces, and much more. Remember what I said about not needing to reinvent the wheel? We have more custom wheels than we know what to do with. One of the first libraries to be used was jQuery, which is still widely used today. To be clear, jQuery is not a framework nor a language. It is a library that is used with JavaScript to optimize development. It can be used with many other libraries. Libraries can also present a challenge to some front-end engineers, as choosing the right tool for the job requires careful consideration and research. No one needs a rocket ship to go to the grocery store, but you also don't want to duct tape a brick to a helium balloon and expect to get to Mars. Tool assessment also involves evaluating and understanding frameworks. As the interactions and needs of web applications have grown more complex, frameworks are an efficient way to build powerful front-end applications consistently and quickly. Frameworks are a packaged set of features that enforce architectural approach to building the front end of a website. Before frameworks, JavaScript had a Wild West approach. Each engineer had his or her own way of architecting their front-end code. JavaScript is somewhat forgiving of poorly thought-out code and therefore easy to write, but sometimes not easy to write effectively. Some of the most common frameworks used today are Angular, Ember, Redux, React, and Meteor. A framework dictates the architecture and behavioral structure of a web application. There are also backend frameworks such as Rails for Ruby, Laravel for PHP, and Django for Python. Frameworks are not a concept unique to front-end engineering. All these frameworks vary in how strictly they force developers to work within their process and enforced limitations. Ember and Angular are the most rigid as well as the most robust, with React and Redux being less so. Ember and Angular excel at large-scale applications that need a lot of functionality, such as Netflix or PayPal. React is great for monitoring user behaviors, such as for sites like Facebook. Angular and Ember also tend not to play nicely with external libraries such as jQuery, which can make development challenging until the learning curve is overcome, whereas React is very accommodating to outside libraries. One thing frameworks cannot do, however, is talk to one another. If a framework is chosen, it's because that engineer has made a full buy-in. The ring, the dress, that application just got married. Unfortunately, the honeymoon period is short. There's a lot of heated discussion in the front-end community around which framework is superior, and I advise anyone who gets in the middle of it to quickly finish their drink at the networking happy hour and slink away before it gets personal. A good front-end engineer will recognize the right tool for the job, and even if that individual hasn't had direct experience in a specific framework, most engineers can get up to speed on the nuances and best practices within a week or 3. We've now expanded on basic knowledge by going over what languages make up front-end and how they work in a web browser. Those languages are HTML, CSS, and JavaScript. We've also had a dive into what JavaScript is, how it works, and what libraries and frameworks are, plus what they are not. Now that you have a clearer picture of the technology of front-end, we'll next move into how engineers solve problems using front-end technology.